As you all know, the integration formulae, that is integration of x to the power n, is x to the power n plus 1 divided by n plus 1 plus c, where c is the integration constant. And these are all some integration formulae. We have some more in the next slide. These are all the formulae for integration of some functions. And here are some more which you need to memorize. While solving the problems, we make use of all these integration formulae. Now let us start with an example. Find the following integrals. The problem 1 is integral of sin x plus cos x with respect to x. This dx represents integration with respect to what variable? Since we have written dx, that means we are integrating our function with respect to x. This is the other question we have, integration of cosecant into cosecant plus cot x with respect to x. Here is the third problem, integration of 1 minus sin x by cos square x. Now let us start with the first solution. We have considered the integral. As we have seen, the integration of sin x and the integration of cos x in the list of formulae. Let us first separate the integral symbol for these two functions. Let us separate the integral symbol. Yes, we have separated the integral symbol here for sin x and for cos x. From the list of formulae we have seen, integration of sin x is minus cos x and the integration of cos x is what? Yes, can you tell me what is the integration of cos x? Yes, it is plus sin x. Integration of cos x is plus sin x. Plus integration constant. We need to write the integration constant plus c for every indefinite integrals. Now let us consider the second problem. In this question, first we need to multiply this cosecant inside. We know cosecant x into cosecant x will be cosecant square x. We got cosecant square x here. Then we multiply cosecant x with cot x. We get plus cosecant x into cot x. Yes, we have written here. After multiplication, let us separate this integral for this term as well as for this term. We have written the integral symbol for this first term along with dx. Here as well we write the integral symbol. Yes, we have written here along with dx. Now from the list of formula we know what is the integration of cosecant square x with respect to x. Yes, can anyone tell me what is the integration of cosecant square x? Yes, it is minus cot x. Now, what is the integration of cosecant x into cot x? Yes, students, can anyone tell me what is the integration here? Yes, it is minus cosecant x minus cosecant x plus integration constant c. So we are done with the question number 2 as well. Now let us start with question number 3. Now how do we integrate this function? So we don't have any rule like integration of u by v. It looks like the function divided by the function. In differentiation we have u by v rule, which is called as quotient rule. But in integration we don't have any such rule for u by v. So we need to bring this function to the standard function, to the standard function, so that we can integrate that standard function. So what is the first step we can do here? We can separate this denominator cos square x for both 1 as well as sin x. Let us separate the denominator now. When we separate this denominator to 1, we get 1 divided by cos square x minus, we write as it is now, minus sin x divided by cos square x. We have separated the denominator. Here we can see. Now let us split this integral for both the terms. I have written the integral symbol for the first term. We will write the integral symbol for the next term as well. Yes, we have written here. Now we all know 1 divided by cos square x is what? It is secant square x. And here, what can be done here? We split this cos square x as cos x into cos x. One cos x we write in the denominator of sin x, and 1 cos x we write separately. Why we have splitted this cos square x? Because we can write sin by cos as tan x and 1 by cos as secant x, which will be a standard function whose integration is available. We have written this as tan x and 1 by cos as secant x. Now what is the integration of secant square x? Yes, students, can anyone tell me what is the integration? It is tan x. Now tell me what is the integration of tan x into secant x? It is secant x. Because when we differentiate secant, we get back secant into tan. We get back secant into tan x. That's why integration of secant into tan will be secant x. Now here we have different methods of integration. First method is integration by substitution. Then integration using partial fractions. Then integration by parts. Now let us see integration by substitution. Here we have one important note. Usually we make a substitution for a function whose derivative also occurs in the integrand. That means, suppose you have an integral and some function, say this is your some function, you are integrating with respect to x. Now we need to take the selection for the substitution. Suppose you have taken this part of the function for the substitution, then its derivative will be the other part. Its derivative, when you differentiate the function which you have selected for substitution, if you differentiate, you will get some other part in the integrand. What is the integrand? This full is your integrand. So we need to keep this in mind at the time of substitution. Now let us observe these things with an example. Integrate the following functions with respect to x. Let us select the question number 2 and solve. Now what is the integrand? This complete function under the integral is your integrand. Now you need to select the part of this function for substitution. Can you observe when we differentiate this x square plus 1, when we differentiate this x square plus 1, what we get? Differentiation of x square is 2x and differentiation of 1 will be 0. So finally what we got? We got 2x, which is here already as a part of integrand. Therefore, we go for this as a substitution. We need to substitute in this place because its derivative is here in the integrand as other part. Here is the reason we are giving derivative of x square plus 1 is 2x. Thus, put x square plus 1 as t. That means we are going to substitute in the place of x square plus 1 as t. When we substitute x square plus 1 as t, we need to check what will be our dx in terms of dt. For that reason, we need to differentiate this equation. Differentiation of x square is 2x and the differentiation of 1 will be 0, which we have not written, into dx by dt. Because we are differentiating this equation with respect to t. Therefore, differentiation of x square plus 1 will be 2x into dx by dt by using the chain rule is equal to, when we differentiate t with respect to t, the answer will be 1, because differentiation of x with respect to x will be 1. In the same way, when you differentiate t with respect to t, the answer will be 1. See, we have written the derivative of t with respect to t, we have written as 1. Since we want dx in terms of dt, let us take this dt to the other side by cross multiplying. So what we get? 2x dx is equal to dt. So you can observe in the question we have already 2x dx. Combining these two, we can replace it by just dt. Let us use these substitutions, this and this, in the given integral. Therefore, the given integral becomes integral of sine t, because we have taken this as t, integral of sine t, and 2x dx will become dt, as we have observed in this step. 2x dx can be written as dt. See, such a complicated function, we brought it to the function which can be integrable. We know the integration of sine t. Integration of sine t is minus cos t plus c. Let us substitute back in the place of t as x square plus 1, because we want the answer finally in terms of the original variable, which was x. For just simplicity, to bring it to the simple level, we had substituted thus. After simplifying, after solution, we need to replace t back by x square plus 1, which we have done here in the last step.